Oh, nice. All right, here we go. So, now, welcome to physics class. Have you ever thought, geez, maybe someday I want to take physics? Well, physics is like problems like this, right, Quinn? Uh-huh. Forces of 5 pounds and 17 pounds act at an angle of 90 degrees. Find the magnitude and resultant force and the angle of the resultant force with the first force. So, actually, let me just make this a little smaller so it fits. Here's an object. Now, the first force is 5 pounds. Does it say the direction of the first force? No, so we assume that to be 0 degrees. That's 5 pounds. Another force acts at an angle of 90 degrees. 90 degrees is up here. That's 17 pounds. So Mr. Hodgin teaches that when you do vectors, you do head-to-tail vectors. So at the end of the first vector, you start drawing the second vector. So it goes here. This is the 17 pounds. So this just gets transferred over to here. Why do we do that? So we can make the resultant vector right here from the start to where the second one ends. Okay? So we have 5 on this side, 17 on this side. This is a right angle. Oh, I have a right triangle. How do I figure out the resultant force, which is the magnitude of that resultant vector? Pythagorean theorem. Very good. C squared equals A squared plus B squared. So, C squared equals 5 squared plus 17 squared. C squared equals 25 plus 289. C squared equals 314. So you take the square root of 314 and you round it to the nearest tenth. What's the square root of 314? 17.7 pounds. Okay? Now, what direction is it going in? Well, it's this direction. Well, what's that direction? Well, if I could find this angle somehow, well, I have an opposite, I have an adjacent. So what trig function is that? Tangent. So if I take the inverse tangent of the opposite over the adjacent, that should give me the answer. What's the inverse tangent of 17 over 5? 71.6 degrees. So that's the angle that it's working at. Okay? 73 point what? 6 degrees. All right. Now my most favoriteest problem of all time in trig. The donkey problem. 2 prospectors are pulling on ropes of red attached around the neck of a donkey who's really being an angle side right now because it's not wanting to move. Okay? Because you know donkeys are angle sides. That's what people call donkeys. All right, one prospector pulls at a force of 55 pounds. The other one pulls at a force of 70 pounds. If the angle of the ropes is 25 degrees as shown in the figure, how much force must the donkey use in order to stay put? Now, the donkey knows the proper direction in which to apply the force. So, these guys are pulling 55 and 70. Is their total force on the donkey 125 pounds? No. If they were smart, it'd be 125 pounds. But these old prospectors are not that smart. Okay? So, for every force, there is an equal and opposite force. So we got to figure out how much the donkey is pulling back at. So, however hard he's pulling back that way is the same as a prospector's force this way. So how do we figure out that force? Again, head to tail vectors. 55 goes this way, and then 70 goes this way. In parallel, these are parallel to each other. Parallel forces. Okay, because this force, you put the other one parallel to it. Okay? So, what we've got here, or you could draw it this way. See how I now have a parallelogram? Now, parallelograms. Opposite angles are congruent. Consecutive angles are what? That's way back from geometry. What's the magic word? Supplementary. Consecutive angles are supplementary. So if this is a 25-degree angle between these ropes, what's a supplement of 25 degrees? 155 degrees. Now, if this is a 70-degree force, all of a sudden, I have a triangle with 55, 155, and 70, and I want to find this side from earlier in this chapter. How do I find what x is if I have a side, an angle, and a side? Law of cosines. X squared equals 55 squared plus 70 squared minus 2 times 55 times 70 times the cosine of 155 degrees. All right. So you put it straight into your calculator, and you get a big old number. What number do you get if you take 55 squared plus 70 squared minus 2 times 55 times 70 times cosine of 155? 14,903.6. That donkey has a lot of force to it if it's got 14,000 pounds of force. But not so fast, my friends. The donkey doesn't have 14,000 pounds of force. Because that's what x squared is. So we have to take the square root of that. So what's the square root of that? 118.8 pounds of force. Now, if the prospectors were smart, they would line up in a straight line. If they would line up in a straight line and both be pulling the same direction, they'd have 125 pounds of force. But by making an angle in between each other, they lose about 6.2 pounds of force. Okay? Because they're not going in a straight line. And that donkey, he's just being an angle side and not moving anywhere. So, all right. So that's how you do the donkey problem. Okay? Here's another classic physics problem. You have a ramp. You have a block of ice weighing 90 pounds on the ramp. You would think the ice would want to slide down the ramp, but there's a lot of friction on the ramp, so it can't slide down yet. What is the force of friction keeping it on the ramp in its spot? Well, from Mr. Hodgins' physics class, the force of friction is going this direction, correct? Its weight is the force of gravity, which is going in this direction. Okay? So if we want to make the force of friction on here, if we go head to tail vectors, we'd go like this, and we draw the line straight down to it. Okay? So, we want to figure out this side. We know the force of gravity is 90 pounds. That's the hypotenuse of that right triangle. We want to figure out x. We know this is a 37-degree angle. That's a small angle of this triangle. So of this triangle, the small angle is also 37 degrees because it's drawn at a right angle or perpendicular to the incline. So we have a 37-degree angle there. The hypotenuse is 90. I want to know the opposite side. Opposite over hypotenuse is what trig function? So the sine of 37 degrees equals the opposite side over the 90 pounds. How do we figure out what x is? Take 90 times the sine of 37. Because if we multiply both sides by 90, x equals 90 times the sine of 37. What is 90 times the sine of 37? There is 54.2 pounds of force, which is the force of friction, which is keeping that block of ice on the ramp still where it is instead of allowing it to slide down. Okay? 54.2 pounds is our force of friction. Okay? So if this kind of interests you a little bit and you're a junior, you should take physics class next year because this is what physics is like, right, Quinn? Uh-huh. Who else is in physics in here? Quinn, you're our only one. You're our only brave soul. Okay. So, take physics next year. It's a good class.